Hey everyone, and welcome back to Act Virtual. My name is Eric Neandros. I'm the CEO of G&A. We're the company that's brought you Act Expo for the last 10 years and now Act Virtual. We're off to a great start these last couple of weeks. I think everyone would agree the content has been amazing. Incredible keynotes, great breakout sessions, engaging discussions in the exhibit hall, tech demonstrations, virtual announcements, press conferences, and a whole lot more. It's been pretty cool, and I hope you've enjoyed it. And there's a lot more to come. In fact, we're going to go all the way to mid-November. Now, I know that sounds like a lot, but remember, we're only going to do a few sessions a month. It's actually every other week for 2 hours on a Tuesday and then 2 hours on a Thursday. So we hope that bite-sized approach really helps to accommodate attending this event in your schedule. One of the other things that I think is really innovative and neat about the online Act Virtual show is the ability to connect with the community and to keep up that networking that we've gotten so used to when attending a conference in person. It's a great way to engage the network and otherwise connect with people in the industry. Now, of course, the show floor is always the star of the show. So I also encourage you to browse around on the virtual trade show floor, check out the sponsors, all the latest products, fuels, technologies, services. It's all there. Each booth has lots of materials that you can download, videos that you can watch. You can have video conversations with the folks that are in the booth. Great way to connect and get information and to keep up the learning and check out all the latest products and technologies. Now, as far as the agenda, you can click on the agenda tab. You'll see the live button right there at the top in terms of which sessions are happening right at that time. You can click on them and away you go. You're right back into the session. Everything's recorded. It will be available on the Act Virtual website. You can go back and watch any of the sessions at any time. Okay, so let's get on with the programming. We've got some great sessions here this afternoon. So thanks for tuning in. Sit back, relax, and enjoy the show.
Hello, everyone. I hope you're all doing okay out there and making the best of things in our new COVID world. My name is Dave Mazaika. I'm the CEO of Coulomb Solutions, and I'm coming to you from Livermore, California, just east of Silicon Valley and about 45 minutes outside of San Francisco, which you see in the picture behind me. Today, I'm here to talk about long life batteries for commercial vehicles. Some can last the life of the vehicle, and some maybe even longer. First, a little about our companies. Coulomb Solutions, Inc., or CSI as we go by, is the North American distributor for CATL's batteries for commercial vehicles. We also carry a line of accessory products. These include most items needed to produce an electric truck or bus, except the main powertrain. CATL, as I'm sure you're aware, is one of the largest global producers of batteries. They currently have production capacity of over 50 gigawatt hours. CATL's batteries are now in over 1.2 million electric vehicles. And they currently have ongoing programs with most major global OEMs. Here's a sampling of some of the battery packs CATL offers for commercial vehicle applications, including buses, trucks, locomotives, and marine. There's actually about 20 different standard off-the-shelf pack configurations, each of which has a variety of cells that can be integrated into them. This makes a total of over 100 different off-the-shelf pack configurations. And this enables us to put together systems to match pretty much any energy requirement or voltage for your particular application. These packs also come with a standard 5-year, 240,000-mile warranty, and extended warranties are also available. You'll see a number of these coming out in various OEM applications later this year. Here's a quick look at CSI's accessory products. These include battery chillers, onboard chargers, cabin heaters, DC-to-DC converters, steering pumps, electric air conditioning compressors, and electric air compressors. These are all very high quality products, easy to integrate, and currently operating in tens of thousands of vehicles. Now, onto our presentation. If we look around the world at where commercial electric vehicles have been successful, it's been largely in China. They currently have over 1 million commercial electric vehicles in operation. Just as a comparison, in North America, we have significantly less than 1% of that. If you look at the battery leaders for those vehicles, CATL and Panasonic were some of the largest producers in 2019 with over a combined output of 60 gigawatt hours. CATL produced a little bit over 30 gigawatt hours. Of that 30 gigawatt hours of total production, about half was NMC and half was LFP. So they really don't have a vested interest in pushing for one technology or the other. Their real goal is to get the right technology in the right application. However, if we look at those 1 million electric vehicles in China, commercial electric vehicles, why did they choose LFP packs? Well, let's take a look at why the OEMs selected LFP for those vehicles. First and foremost, we look at safety. LFP cells are inherently safe. They're extremely difficult to have them misbehave. And when they do, they only smoke at high temperatures on electric vehicles. NMC cells, however, are much more volatile. And in developing packs, you need to include anti-propagation materials to prevent runaway conditions. Now, with some of the newer formulations, such as you see in the chart, the newer ones, such as 811, they have lower thermal stability temperatures than some of the older formulations, such as 523 and 333. However, this just means that better care needs to be taken in the anti-propagation materials and also in the pack assembly. So LFP packs the LFP technology does have an inherent advantage in safety in commercial vehicles. And this was especially important for those first set of 1 million vehicles in China, where a large percentage of them were transit buses carrying a lot of people. Now let's take a look at the specific energy, or how much energy per unit weight is in typical battery packs. The specific energy is usually measured in watt hours per kilogram and goes to the overall weight of the pack. Weight is extremely important for commercial vehicles. Since commercial vehicles usually make their money by hauling cargo, having a battery pack with excess weight can start to impact their load carrying capability. Now, if you look at the specific energy of just at the cell level of NMC at 230 watt hours per kilogram, that's certainly significantly higher than LFP at 180. So you would think it would have a significant advantage in overall pack weight. However, because of the anti-propagation materials that have to be added to the NMC systems, and the fact that they're generally integrated into modules before integrated into larger packs, this drops the overall specific energy of NMC packs down roughly to an equivalent level of LFP at about 160 watt hours per kilogram. And just taking a couple of examples of high volume commercial packs out there today, Tesla's Model 3, certainly a leading vehicle out there, has a specific energy of about 159.9 watt hours per kilogram. Happens to be NCA chemistry. Whereas CATL's LFP packs have a specific energy of 160 watt hours per kilogram as well. So as you can see, the weight of those packs with both technologies would essentially be the same today. So there's really not a weight penalty anymore for using LFP. One process which CATL uses to increase the specific energy of its LFP packs is called CTP, or cell to pack. Since the LFP cells do not require the anti-propagation materials, they can be directly integrated into the pack without going through the module step. By skipping the module step, that eliminates a number of parts and also simplifies assembly. Reducing the number of parts, of course, increases the specific energy of the pack, while simplifying the assembly really lends itself well to automation, which lowers the cost. Now let's take a look at energy density, or the amount of energy per unit volume that can be stored in a pack, usually in watt-hours per liter. This is an area where NMC has a distinct advantage over LFP. Typically, an LFP pack will be about 20% bigger than an NMC pack with the same energy. And this is a key reason that many passenger cars today use NMC packs. Really, that was the best way for the OEMs to be able to integrate enough energy into the car to be able to meet the range requirements that they wanted. So that is a big advantage in passenger automotive. However, in heavy-duty vehicles, where space is generally pretty abundant, it's not really a big factor. The cycle life between NMC and LFP is a big differentiator. When you're comparing cycle lives, it's extremely important to make sure that your cycles you're comparing are the same. With CATL's batteries, they're capable of doing 4,000 100% DOD, 1C charge, 1C discharge cycles. Now, there are some NMC cells that can also do 3,000 to 4,000 cycles. However, those are typically tested at a rate of C/3, or 1/3 the power, and they're also only done from 80 to 90% depth of discharge cycles. Now, the 1C rate we feel is very important for commercial vehicles. If you have a truck that's going up a long grade, it will typically be running at a 1C rate. If you have a heavy truck that's doing a fast charge, it can also be doing a 1C or even higher rate. So even though the average power used by these heavy trucks can be significantly lower than 1C, when it is operating, a significant portion of the time is at 1C. We also think that 4,000 cycles is extremely well matched to commercial vehicles. So if you take a typical truck, say it charges 350 days a year for 10 to 12 years, that's 3,500 to 4,200 cycles. So as you can see, the 1C rate and the 4,000 cycle life of the LFP chemistry is extremely well matched to the requirements of today's commercial vehicles. Now, let's say you're one of those fleets that drives your trucks until the wheels fall off. Maybe you drive them 14 to 15 years or even longer. Well, then CATL's new super long life or million-mile technology is for you. This technology is capable of doing 12,000 100% DOD, 1C charge, 1C discharge cycles. Now that's pretty amazing. And it doesn't require any new mystery technology breakthrough to bring to market. In fact, CATL currently uses this technology in its stationary vehicle batteries, which are doing grid support operation. So this technology is now being ported over to the vehicle packs where it's really needed in the very long life applications. We think it's going to be interesting to see now that you have batteries and also electric motors that are capable of lasting much longer than the lifetime of typical vehicles today. Is that going to drive people to have longer life vehicles, or maybe swap out batteries between one generation and the next generation vehicle? It could open some entirely new business models. Let's take a look at cost. Now, we've all seen many of these cost down curves for batteries, and certainly there's a general agreement that over the next decade, battery costs will continue to drop, and that's great. But what's not typically shown is that LFP packs are usually about 10% lower than the cost of NMC. And that's for two main reasons. First of all, the NMC packs have to include the anti-propagation materials and also extra components to integrate them into modules before moving them into packs. And secondly, the NMC cells use cobalt, which is generally expensive, sometimes hard to find, and can also have pretty volatile pricing. Now, some companies are working on removing the cobalt out of the NMC chemistry, and that would certainly make things better, but we still believe that there's going to be a substantial advantage to the LFP cost by not needing the anti-propagation materials or integrating them into modules. So we expect that this 10% lower cost is going to continue to push LFP into more and more applications. Now let's take a look at the cost impacts of the million-mile technology. When CATL first came to us, it took us a while really to understand the impacts financially of the million-mile technology. How does that really impact your operating cost or your pack amortization if your batteries can all of a sudden go from 4,000 cycles to 8,000 or 8,000 to 12? Well, let me help you bring that into some real world numbers. Let's say you had a battery pack that was priced at $200 a kilowatt hour and you had a 200 kilowatt hour pack. Well, that battery pack would cost you $40,000. If you take the $40,000 and divide it by 4,000 cycles, that pack would cost you $10 per cycle, or about $10 a day if your truck typically goes through one cycle of your battery. Now, if you have an NMC cell, which is only capable of half of that cycle life, well, that's going to be $20 a day for your amortization of that. And since NMC in general costs more than LFP, it's actually even a little bit more than double the cost per day. Now let's go the other direction. If you move to CATL's chemistry, that's their long life version with 8,000 cycles, it doesn't quite cut the cost per day in half because, of course, the technology itself costs a little more than the standard technology. But as you can see, it's not too far from that. And actually, if you move to the million-mile technology or super long life, there it's pretty close to exactly half of what it would be today. So instead of costing them roughly $10 a day, it's now only going to cost you $5 a day for your battery pack. So where, just by changing pack technology, where else could you lower your amortized operating costs by 50 to 75%? I think those opportunities are really hard to find, and bringing this technology out into commercial vehicles is going to make them extremely cost effective on total cost of ownership models. And we look forward to talking to you fleets about this technology and putting together the numbers for you. So to summarize, for commercial vehicle applications, LFP has some very distinct advantages. LFP has the advantage of being inherently safer than NMC technology. LFP current specific energy is roughly the same as that of NMC, so there really isn't an advantage in the weight of the packs either way. The cycle life of LFP at 4,000 cycles, even just with the standard CATL LFP technology, is very well matched to the life of today's commercial vehicles. And the cost for LFP versus NMC is about 10% lower. And that's a big advantage straight out, not even taking into account the extra number of cycles that you get from LFP. If you take that into account and look at the amortization, that will reduce your cost per day by 60 to 80%. So a huge improvement. The only disadvantage to the LFP is the packs are larger. So our rule of thumb is if the LFP packs fit, use them. So that's the current state of technology as we see it. But what does the future hold? We hear about battery breakthroughs many times a day, but how many of these will ever really see the light of day and make a significant difference? Let's see what the leaders in EVs think. Well, CATL now has battery systems in over 1.2 million electric vehicles, and those have traveled 43.6 billion miles. CATL also has battery systems in over 270,000 commercial vehicles, and those have traveled 25.7 billion miles. So as you might imagine, this has provided CATL with unparalleled experience in both passenger automotive and commercial vehicle batteries. If we take a look at the electric vehicle manufacturers, certainly Tesla has been the leader in 2019, producing almost 370,000 units. In addition to being a leading electric vehicle manufacturer, they also have their own battery gigafactories, which gives them extensive experience in battery pack manufacturing. So what do these two industry leaders see in the future? Well, one big indicator may be in their latest announcement, where CATL will be providing their LFP batteries for Tesla's Model 3s in China. Now, why would Tesla do this when they have their own gigafactories making their own batteries? Well, I think the reason is actually quite simple. Tesla was able to package enough of CATL's LFP batteries into the Model 3 to achieve the range that they needed, and they could do that at lower cost. The lower cost enabled Tesla to match the price of the other available electric cars in China. And for those of you who don't know, it's actually a very competitive market. Matching those prices also enabled Tesla to be able to qualify for the local subsidies. Now, we don't think that LFP is going to be taking over the passenger car market, as some of these stories that came out at the time seem to imply. However, we do believe that the lower cost of LFP is going to push LFP into more and more applications, especially as the specific energy and energy density increases. So this is the roadmap we see for commercial vehicle battery packs over the next decade or so. The LFP chemistry will continue to increase in specific energy to well over 200 watt-hours per kilogram, which will lower the weight and cost of these systems by about 25%. At some point, there will be a transition to solid-state batteries. These will likely start out with only limited performance improvements over currently available models, but the safety will be much improved. Solid-state batteries, of course, hold the promise of doubling the specific energy and greatly increasing the cycle life over today's NMC cells, and that certainly will come over time. Of course, the $24 million question is, when will the transition to solid-state batteries really occur? Will it be in 2025, as some OEMs have announced their product launches? Or will it be closer to 2030, which would be my personal opinion? I guess we'll have to wait and see. It's been my pleasure to share these thoughts on commercial vehicle batteries with you. I'll be around for the Q&A session after this, or if you have any questions and want to contact me afterwards, certainly feel free to email me at dave@coulombsolutions.com. Thank you, and I hope you enjoy the rest of the conference.
Scroll on over to the breakout sessions. Check out just one or try them all. Also, our virtual exhibit hall is now open. Stop by and meet one-on-one with our sponsors.